All right, so here's problem 551 from the 10th edition of Margnacki. A heat engine receives 7 kilowatts from a 300-degree source and rejects 60 degrees Celsius. Did I say that? Okay, anyway. Examine each of the three cases with respect to the inequality of Clausius. Very exciting. And let me turn up the brightness. I think these get too dark. I should have done that before in the other videos. All right, too well. Let's see. We're given these temperatures. Let's go ahead and turn these temperatures. So this is the high temperature, 300 plus 273, and that becomes 573 degrees Kelvin. And the low is 60 plus 273. So make that equal 333 degrees Kelvin. And we also have, it's a heat engine, so the conservation of energy would be 0 is equal to Q dot H minus the heat rejected minus the work out or power out. It's got a W instead of a U. I don't know why I did that. Anyway, let's see. So for the here's A, and we have 2 kilowatts. And so let me see. Let's see the heat rejection. So it receives 7 kilowatts. So I should have written up above that this right here. The H was equal to 7 kilowatts, right? All right. So here you go. Bound in here. Let's find out what the QL is going to be. So 0 equals 7 kilowatts in. Minus Q dot L, and then minus 2, right? So we end up with that QL is going to be 5 kilowatts. And this is out, rejection, heat rejection. Now that was like too bright. There you go. It's because of this lamp. You get a better lamp. And okay, so here's inequality of Clausius. That's not an F, that's an integral. dq over t around the whole cycle. That ends up being qh over th plus ql over tl. And remember that is out, so it's negative inherently. So we get 7 kilowatts divided by 273, and then let's go ahead and make this negative right there. Not 273, 573, 573, 573, sorry, 573. And here's 333. Is that right? Yeah, so it's surprising actually. It's a pretty damn small number. It's still negative though, 0.00. I could call it 8, but it's 799. And if you wanted the units, doesn't really matter, but these are kilowatt degree Kelvin. Right now I'm annoyed by that light. Okay, there you go. Can't quite see the thing because we get glare. We get glare. Get glare. We're going to glare, sir. Glare. Okay, there you go. And okay, so yes. Therefore, yes. It obeys the with it is examine these three with the yes. It obeys, or it agrees. It satisfies. There you go. Satisfies Clausius inequality. And then go to B. Similar things, you could do the math in your head. 0 equals 7 minus Q dot L minus 5. Q dot L is equal to 2 kilowatts. It's out. So we can make the up here the Clausius thing. del Q over T. And so I just plug them in, right? So it's going to be 7 over 573 minus 2 over 333. Or I could have put that plus that, I could put that minus right in there and make that it's out. And what you find is you get 0.00621 kilowatts per degree Kelvin, and therefore no, doesn't satisfy. Satisfy, I guess that's right. C is a Carnot cycle. So what is a, okay, so we have to first find, here's a little trick, if you will. I don't know if it's a trick. It's necessary. Find the Carnot efficiency. And that's going to be this right here, divided by Qn. But it's also going to be equal to 1 minus TL over TH. So we get 1 minus 333 divided by 573. And we get 41.89%. This page is like, I can't get it up to move it up. There you go. And so now what we could do is find, now we could find, because we have the Qn of 7, so we get this right here out is going to be the Carnot. It's the Carnot engine times Qn. So 0.4189, and that's going to be 7 kilowatts, so we get 2.932 kilowatts. And what we'll find for, and then if you go back to, this thing, go 7 minus Q dot L minus 2.932, Q dot L is then going to be 4.068 kilowatts. And the inequality of Clausius becomes 7 divided by 573 minus, here's the losses going on, plus minus, right, because these are out, 4.068, did I get that right? Yeah. Divided by our 333. You do the math, and it comes out to 0, and therefore you're going to go, okay, it satisfies, because the Clausius statement is, I keep doing it as must be negative, but the Clausius statement can, in fact, and I've lost that piece of paper. He's gone. What'd you do with him? I don't know. What'd you do with him? Oh, here he is. This one right here. It says it must be less than. I don't know. Maybe we should say that it violates it. Because that's the Clausius inequality says that it will be less than. What, is there any place that officially says? Let's take a look at the last page of these notes right here. Okay, there you go. There you go. There's where it's written down. Equation 518 in the book says less than or equal to. So that's going to make our decision for us that yes, it obeys it. Okay. There you go. 9-minute video, good enough. Let's make a new video. See you in the next one for class 19. Maybe I'll see you. Yeah.